Good afternoon, everyone. Am I audible?
Yes, good afternoon.
Good afternoon,
Am I
sir.
audible? Okay.
Yes,
So
sir.
let's begin. Yesterday. So far, what we have seen, we had seen a system of linear equations. Okay, this is a system of linear equation. Here it is. If Bi's are all Bi's are 0, then we call such a system of linear equation a homogeneous system. Correct? Yesterday we saw some examples where there was only one solution, where there was no solution, and there was infinitely many solutions. Based on these, we classify a system of linear equation. Okay, what is the classification? So classification is simple. So it is, there are two, so we have system of linear equations. So their system will be either consistent or it would be inconsistent. Consistent means there exists a solution. And inconsistent means there does not exist any solution. So in consistent system, yesterday we saw there exists a unique solution. So it may be unique, solution may be unique, or there exist infinitely many solutions. Correct?
Yes, sir.
Yes, sir.
Okay. So this is what we have seen yesterday. Now, as I said yesterday that you have already know this subject, you have already know how to solve a system of linear equation. So I have sent you a book by Hoffman and Kunze. So the first chapter of that book is in that chapter you will find how to solve a system of linear equation. Okay, you will find many more things about matrices. So please read that book, and if you have any doubt, then ask me. Okay, and try to solve each and every question of that book. And why I am saying this? Because this linear algebra course is very important for other courses of mathematics as well as for your NET examination. So do you all know what is NET examination? NET? You all know this? Have you heard about NET?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
National
3
Eligibility
marks
Test
हो जाता है linear में.
for lecturers, and for if you do a PhD, then you get some fellowship from UGC or CSIR. So UGC and CSIR both mean they conduct this NET examination. Okay, jointly they conduct this. So and there are plenty of questions from linear algebra. So please do attempt questions from the text.
हेलो
हाँ बोलिए.
सर, आपकी आवाज बहुत स्लो आ रही है.
बहुत स्लो आ रही है मतलब कि
मतलब बहुत धीरे आ रही है, मतलब बहुत कम सुनाई दे रहा है. दो वॉल्यूम फुल है बट फिर भी बहुत कम आ रही है.
आप हेडफोन का यूज कर सकते हैं. हो सकता है मेरा
ये सर
डिवाइस
लगा
खराब
हुआ
है.
है, हेडफोन लगा हुआ है.
असल में दिक्कत क्या है कि मैं अपने डिवाइस का वॉल्यूम बहुत कम नहीं रख सकता. मीन्स इसका वॉल्यूम. एक मिनट रुकिए, मैं दूसरा कुछ ट्राई करता हूँ. अगर वो ठीक बैठता है देखते हैं क्या होता है. ठीक है, लेट मी डू दिस. मैंने फुल वॉल्यूम कर दिया है और अब देखते हैं. हेलो.
ये सर अभी आ रही है.
हाँ जी सर, अब क्लियर आ रही है और तेज भी आ रही है.
ये सर
अभी अभी ठीक है ना आप लोगों को?
यस सर, ओके है.
यस सर.
ओके चलो, बहुत बढ़िया. मैं क्या बात कर रहा था? मैं नेट के बारे में बात कर रहा था. ठीक है, तो आप लोगों को लीनियर अलजेब्रा जो कोर्स है ये नेट पास करने का एक बहुत अच्छा साधन है. आप लीनियर अलजेब्रा में मास्टरी करिए तो आपको नेट पास करने में बहुत मदद मिलने वाली है. और मैं आपको साथ साथ कुछ बुक्स बताते रहूंगा. मैं पहले कुछ बुक्स के नाम लिख देता हूँ. एक बुक मैंने आपको भेजी है. ठीक है.
यस सर, बहुत अच्छी बुक है.
हाँ, और दूसरी क्या हो रहा है देखो. दूसरी बुक है डेविड सी ले, ये ऑथर का नाम है. बुक का टाइटल शायद लीनियर अलजेब्रा ही होगा. ठीक है. एंड देयर इज ए बुक नेम 3000 प्रॉब्लम्स और ऐसा कुछ नाम है लीनियर अलजेब्रा. ये बेसिकली आपके प्रैक्टिस के लिए बुक है. I don't know about author, but what I know is it's Shom's book. Shom, spelling mistake हो सकता है मुझसे. Shom's series, टाटा मैग्रो हिल की बुक है. ठीक है. Okay. Then there is book by S. Kumaresan. Title is Linear Algebra, a Geometric Approach. Okay, and then Hoffman Kunst तो मैंने बोला है आपको. बुक बाय हालमोस, बहुत ही अच्छी बुक है. नाउ टाइटल इज फाइनाइट डायमेंशनल वेक्टर स्पेस. vector species. Okay, and then okay, this is very nice book. Artin, title is Algebra. So you will find group theory, ring theory, field theory in this book, as well as linear algebra. Artin's book, its approach is geometric. And one last book by नाम शायद algebra है, बुक का नाम हो सकता है abstract algebra हो. I don't know the exact wording. Okay, you may take a screenshot of this part. जब स्क्रीनशॉट ले लिया हो तो मुझे बताइएगा, मैं आगे बढ़ूंगा.
हो गया.
हो गया ना? ठीक है.
Yes,
आप ये बुक फॉलो करिए, आपको बहुत कुछ सीखने को मिलेगा. ठीक है, क्योंकि हम लोग तो सिलेबस तक ही सीमित रहेंगे. बुक्स में आपको और भी ज्यादा चीजें मिलेंगी, तो बुक्स पढ़ने की आदत डालिए. करेक्ट?
करेक्ट सर.
ओके. हाँ. So we have classified the system of linear equation. So there were two types of systems. One was consistent, other was inconsistent. So inconsistent is of no use for us. So let's see about consistent. Okay. And basically, what I am interested in is system of homogeneous linear equation. So I have one question. So there is one question for you. Is a homogeneous system consistent? What is your answer? बताइए.
No, sir.
No solution होगा, no solution.
हाँ.
No, sir.
सर ये कंसिस्टेंट रहता है, इसमें जीरो सोल्यूशन तो हमेशा इसका रहता है.
Okay. So this means homogeneous system is always consistent because say we are the system is of m equation in n variables, so x1, x2, xn. If we take each xi 0, 0, 0, then this is a solution. It's a solution for a homogeneous system in n variables. Okay. So, and we call this a trivial solution. We call this a trivial solution. So answer is
Solution.
no. हाँ हाँ कुछ बोले साक्षी?
No sir.
Okay. Okay. If a homogeneous system has a solution other than 0, so what does it mean by x1, x2, xn not equal to 0, 0? This means there exists some xi which is non-zero. Okay.
Yes sir.
So if this is the solution, then it is called a non-trivial solution. Then x1, x2, xn is called a non-trivial solution. So why are we interested in these solutions? So we will see this. Okay. But you know, so you have seen that you correctly answered that a homogeneous system is always consistent, but there might exist a system of homogeneous a homogeneous system of linear equation where there is no non-trivial solution. For example, if you consider क्या हो रही है?
आवाज इको कर रही सर आपकी आवाज.
हाँ वो मुझे भी इको सुनाई दे रहा है इसलिए. ओके, मैं थोड़ा सा वेट करके बोलता हूँ. if we take this system in two variables, x equal to 0, y equal to 0, this is a homogeneous system in two variables. This system has no non-trivial solution, correct? So this means what I said, a non-trivial solution need not exist. Okay? Okay, why? Let's see structure of solutions. So why are we interested in this solution set? Correct? So first we consider a system, homogeneous system. So let's write it again. So A11x1, A1n xn equal to 0, AM1x1, AMn xn equal to 0. I may write it as summation. What should I write? Summation j runs 1 to m a I a not I a j. Let me check it. So it's not m, it's n a j equal to 1 to n a I j x j equal to b j. Okay, here what is less than equal to I less than equal to one minute. So this is not j. This would be I, because so we can write this system in this format also. Correct? Okay, if we have this system, so let's see the structure of solution set. If we have a non-trivial solution, so we are assuming that if we have a non-trivial solution, then what can we say about other solutions? Okay, suppose we are in R3. So R3 is the largest dimension where we can see the things. Okay, so say we are in R3 and we have a system of homogeneous equation like this, and assume that A, B, C be a non-trivial solution. Be a non-trivial solution. Okay. So suppose we are taking only one equation here. A1x1, A11x1, A2x2, A3x3 equal to 0. This is, so we are in three variable and we have only one equation. Okay, one linear equation in three variables. Correct? Be a non-trivial solution of this. So what can we say? So do you know, yesterday some of you correctly answered what this equation look like in R3. So what does it represent in R3? Please answer. Hello?
Yes, sir.
Yes, sir.
What does this equation represent in R3?
Plane.
Plane, but that plane will pass through origin. Okay, so 0, 0, 0 is a point
Yes, sir.
that plane, correct? Because 0, 0, 0 is the solution of it, correct? So this is a plane, say such kind of plane. where this 0 point is there. So this is a plane in R3. Okay, now what we see, so suppose this is a point A, B, C. This point is A, comma, B, comma, C. And this is our origin, 0, 0, 0. Okay. Now, you know, if we make a line passing through 0, 0, 0 and at this point A, B, C, passing through this and this, तो ये थोड़ा सा गलत बन गया, कैसे बनाएंगे? Okay, this is the line passing through 0, 0, 0 and ABC. So let's see. So can anyone tell me what will be the equation of line passing through A, B, C and 0, 0, 0? Okay, first recall something from your 11th class coordinate geometry. Suppose, okay, so this is for recall. Suppose you have a point A, okay, you have a vector A, and you have a direction B. B is another vector. So A and B are two vectors. Hello. बोलो बोलो अर्पित कुछ बोल रहे हैं आप? किसी ने कुछ बोला, हेलो बोला, फिर वो चुप हो गए. अर्पित
सर आप कंटिन्यू करिए, नहीं बोलेंगे.
हाँ ठीक है, आप अपने को म्यूट कर लीजिए. आप लोग खुद को म्यूट कर लीजिए, जब बोले तभी आप अनम्यूट कीजिएगा. रोहित म्यूट कर लो. ठीक है. Suppose we have two vectors in R3, A and B. Okay, so I'm asking you, how do we write a line? Actually, it should be the line passing through A and in the direction of B. Do you know this? How do we write this line? How do we write the equation of this line? Anyone? Arpit? Okay, if you forget, let's recall it. हाँ हाँ
इस लाइन का इक्वेशन होगा वेक्टर ए प्लस एन और वेक्टर बी.
वेक्टर ए प्लस
वेक्टर बी
n vector b, where n is, what is n?
something is missing.
What is n?
Missing some point.
डायरेक्शन कोफिशिएंट.
हाँ, वो कोफिशिएंट कहाँ से आएगा? What is that
डायरेक्शन
coefficient?
कोफिशिएंट.
हाँ, so I'm asking what is that coefficient? डायरेक्शन कोफिशिएंट मतलब वो कोफिशिएंट कहीं से आएगा ना, कुछ होगा. Okay, no problem. We will talk about this. What is n? This n is nothing but a scalar which is a real number. Okay.
Sir, n is
So n is real number. N is a real number. Any real number. Okay. So generally we represent n. So we represent positive integers by n. So I will write, I will replace n by some alpha. Is it correct?
Yes, sir.
Okay, let's see. Okay, so let's go back to our situation. So here, what we have 2 points, 0, 0, 0, and a vector A, B, C. Now we want to find the equation of line passing through 0, 0, 0 and ABC. Correct? And we know this thing passing through A and in the direction of B. So let's find the direction of ABC. What would be the direction of ABC? So it is ABC. So if you have a vector A and you have a vector B, so how do you find the direction of line passing through A and B? That is B minus A. Correct? Do you remember this? Hello? So here my A is origin, B is ABC, so it is ABC only. So therefore, this line, which is in blue color, this line, it is represented by this equation. So A means 0, 0, 0 plus alpha A, B, C. This is nothing but 0 plus alpha A, 0 plus alpha B, 0 plus alpha C, and we know this is alpha A, alpha B, alpha C, where alpha is any real number. Correct?
Yes, sir.
Okay. And it's easy to see that if A, B, C is a solution of this equation, then alpha A, alpha B, and alpha C will be a solution of this homogeneous equation. Right? So this means if I represent A by A, B, C, then I would say alpha A will also be a solution. Okay. So far what we have seen, if A is a solution, then alpha A, which is scalar multiplication by a scalar alpha, where alpha is real number, is again a solution. Okay, let's note that. Note it, if A is a solution, then alpha A is also a solution. So I will not write this vector. So and I will omit this as well. If A is a solution, then this is one observation, and in fact we have proven. Now let's come to another situation. Say we have two different non-trivial solutions, A1, A2 and A3, and B1, B2, B3, B2 different non-trivial solutions. Okay. Then let's see what happened to A1. Okay. A2, A3 plus B1, B2, B3. So whether this will be a solution or not. So here A1 plus A2 plus A3, it is defined as A1 plus B1, A2 plus B2, A3 plus B3. And it is easy to see, just replace these X. Oh, ये थोड़ा सा गड़बड़ है. Let me write not A1, A2, A3. Write alpha 1, beta 1. Okay. Alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, So this will be alpha 1 plus beta 1, alpha 2 plus beta 2, alpha 3 plus beta 3. Okay, now let's see this equation. A1 x1, A2 x2, A3 x3. Write it here. A1 x1, A2 x2, A3 x3 equal to 0 if this was alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3. So these are two solutions. This means A1 alpha 1, A2 alpha 2 plus A3 alpha 3 equal to 0 and A1 beta 1, A2 beta 2 plus A3 beta 3 equal to 0. So let's replace x1 by alpha 1 this, x2 by this and x3 by this and see what happens. A1 alpha 1 plus beta 1, beta 2, alpha 3 plus beta 3. So what you get? You get alpha 1 A1. Okay, I'm writing it like this. Plus A1 beta 1, A2 beta 2, A3 beta 3. So from here, this part is 0, this part is 0. So this is 0 plus 0 equal to 0. So what we have seen is if these two are solution, this again a solution, then is a solution. Any doubt? Hello?
Yes, sir.
Is it okay?
Yes, sir.
Okay. So
Sir,
what we have seen,
पॉइंट्स के लिए भी प्रूव कर सकते हैं ना
क्या क्या हाँ ऐसा 3 पॉइंट के
सर
लिए भी
ऐसे
प्रूव
ही
कर सकते हैं बिल्कुल हाँ हाँ
ओके सर थैंक यू
बिल्कुल 3 पॉइंट के लिए भी कर सकते हैं सो व्हाट वी हैव proven so far, let me write in other words. So the set of solution, so what we have proved is if we have two solutions, then there some will again be a solution. If we have a non-trivial solution, then if we scale it, means when we multiply that solution by any scalar, it will again be a solution. So this property is called closed under addition and closed under scalar multiplication. This means the set of solutions of a homogeneous system of linear equation is closed under addition and scalar multiplication. Okay. So let's compare the solution set of homogeneous system and non-homogeneous system. So is this thing true? Is this statement that I just wrote is true for a system of non-homogeneous equation?
So need not be true.
Need not be true. Okay, very good. Why so? If we say just take x plus y equal to 1, okay, so 1 by 2 comma 1 by 2 is a solution, a non-trivial, so it is a solution of this
Non-homogeneous.
equation, non-homogeneous equation. Okay, so this one is a solution. If we multiply this by alpha, it will be alpha by 2 comma alpha by 2. If alpha is not equal to 1, then it will not be a solution of this equation. Correct?
Yes, sir.
Okay. Second thing, if I take this sum, then this comes 1 comma 1, and we see this is not a solution of this equation again. Correct? Correct or not?
Correct.
Okay. So this means this statement is not correct for a non-homogeneous system of linear equation. Okay. So let's talk about solution. So how do they both related? So for every non-homogeneous system of linear equation, you have a homogeneous system of equation. Okay. So take summation j equal to 1 to n a I j b x I equal to b I, where where uh, I runs from 1 to m. So if b sum of bi are non-zero, for some I, if they are non-zero, then there is an associated homogeneous system. That homogeneous system is given by this thing. Correct? We just replace bi by 0. So is there any relation between solution of this homogeneous system and solution of the non-homogeneous system? Let's see this. Okay. So let's see how should I write this. Suppose alpha is a solution of the non-homogeneous equation, non-homogeneous system. Correct? And uh, beta is a solution of the associated homogeneous system. Okay. Then let's see what happens with alpha plus beta. Is this a solution of non-homogeneous system? Will it be a solution? क्या सोचते हैं आप लोग, क्या ये सॉल्यूशन हो पाएगा? हेलो, हाँ बताइए. Hello. So let's do this. Say alpha is alpha 1 to alpha n, beta is beta 1 to beta n. Okay. So from this thing, alpha is a solution of non-homogeneous system. So this means summation j 1 to n aij. If I replace xj by alpha j, I will get beta j. Sorry, beta j. Correct? Not beta j, beta I. Correct? प्लीज कोई तो कुछ बोलिए जिससे कि मुझे लगेगा पहुंच रही आवाज। हेलो, एम आई ऑडिबल?
सर
Yes, sir, audible.
आप बीच में हाँ ना कुछ ऐसा बोलते रहिए, ठीक है?
Okay, sir. Okay, sir.
Okay. So when alpha is a solution of non-homogeneous system, so we have this term. And we have also said that beta is a solution of associated homogeneous system. This means we have summation j1 to n aij beta j equal to 0. Correct?
Yes, sir.
Now what is alpha plus beta? Alpha plus beta is alpha 1 plus beta 1, alpha 2 plus beta 2, and so on, alpha n plus beta n. And let's see what happens with this. And we take summation j1 to n aij alpha j plus beta j. Let's consider this part. So this will be summation j1 to n aij alpha j plus aij beta j. Okay? This is just a calculation. So from here we get aij alpha j plus summation aij beta j. From the first equation, this first part is beta I, and from second this is 0. So this means this is beta I. Okay?
Yes, sir. Okay.
This shows that alpha plus beta is again a
Solution.
solution of non-homogeneous. So this
Okay,
means
sir.
this set, if S is the solution set of non-homogeneous system and SH is the solution system of associated homogeneous system, okay, then for any fixed alpha in S, alpha plus SH is contained in S. This is what we have proven. Do you see this? ये समझ में आया आपको? हमने क्या प्रूव किया अभी?
Yes, sir.
हमने एक एलिमेंट लिया था S से और कोई भी आर्बिट्ररी एलिमेंट हम SH से यूज उठाते हैं, हम देखते हैं कि अल्फा प्लस SH फिर भी सॉल्यूशन, फिर से सॉल्यूशन में. Where let me write this for you, where alpha plus SH is nothing but alpha plus any beta, where this beta comes from SH. Okay. So this is first part. Let's see another part, whether S is contained in alpha plus SH or not. क्या ऐसा होगा? Let's see this. So for this, choose a point in S means a solution of non-homogeneous system, correct? So what you do this thing. Z equal to अल्फा लो आप और साथ में प्लस Z माइनस अल्फा करो, ठीक है? ओके, so Z will be alpha plus Z minus alpha. So let's see whether Z minus alpha belong to SH or not. क्या Z minus alpha homogeneous system का solution होगा? बताओ. हेलो, अगर मैंने Z और अल्फा दो सॉल्यूशन लिए नॉन होमोजेनियस सिस्टम के, अगर मैं नॉन होमोजेनियस सिस्टम का सॉल्यूशन ले रहा हूँ तो जब मैं करूँगा समीशन J1 to N Aij, ओके, Zj माइनस अल्फा j, तो मुझे क्या मिलेगा? समीशन J1 to N Aij Zj माइनस Aij अल्फा j। जो पहला पार्ट आएगा वो bi आएगा क्योंकि z एक सॉल्यूशन था इसका नॉन होमोजेनियस का, और अल्फा भी एक सॉल्यूशन है नॉन होमोजेनियस का, सो दिस इज माइनस bi, सो आई विल गेट 0, करेक्ट? हाँ या ना कुछ बोलिए।
Yes, sir. Correct.
So this means z minus alpha is a solution of homogeneous system. So this means z minus alpha belong to SH, correct?
Correct,
So
sir.
from here, from this part, what we infer is that this z belongs to alpha plus SH, okay? And this z was arbitrarily chosen, therefore S is a subset of alpha plus SH. And you already have proven at this place that alpha plus SH is a subset of S. This implies S equal to alpha plus SH. Correct? Okay. So what we have in fact seen, or what we have in fact proven, is this thing. So to find, write it in red color, to find all the of a non-homogeneous system, it is enough to find all the solutions of the associated homogeneous system and one particular solution of non-homogeneous system. Do you see this? So that's what we did here. So this alpha was the particular solution of non-homogeneous system, and SS was the set of all solution of homogeneous system. So with these two, we can find all solution of non-homogeneous system. Correct? Okay, this is the thing that I should say. Wait for few seconds. Okay, let's again do. Let's move ahead. So here is an exercise for you. The system okay, if we have a system of m linear equation in n variable, if m is strictly less than n, then this homogeneous system has a non-trivial solution. So this is an exercise, and in fact it's very interesting result that you should know. Okay, so try to prove this. So this is an exercise. Now, I'll give you definition of a vector space, and I will. Where did I write that thing? So, okay. So from this observation, let's define a vector space. So you all know a vector space. So since you have studied this, I am assuming that you know what a vector space over a field is. You all know it is also called a linear space. Do you know this fact? Vector spaces are also called linear spaces.
Yes, sir.
Hello? Okay.
Yes, sir. It
This
is also
thing,
called linear spaces.
it comes from this fact that these vector spaces can be seen as a system of a solution set of a homogeneous system of linear equations. Okay. So since these are solution of system of linear equations, homogeneous system of linear equation, therefore it is called linear space. So here what we saw is the solution set is closed under addition and closed under scalar multiplication. Okay. So let's generalize this thing. So far what we have seen the addition and scalar multiplication, correct, on the set of solutions of a system of a homogeneous system of linear equation. This set is closed under addition and closed under scalar multiplication. We call such a system, we call such a solution set a vector space. So let's define. So it is a more general notion. So if you remember, if you, if you remember, where did you first learn this subject? You learned this in abstract algebra. Do you know what is the meaning of
Sir.
abstract?
You
Do you know the meaning of abstract? हेलो
सर
हाँ आवाज आ रही है
आवाज ही नहीं जा रही
हाँ सरोज बोलिए
सर
आपकी
जो
आवाज
आपने
आ रही है
एक्सरसाइज
मुझे।
दी
हाँ
सर जो आपने क्वेश्चन दिया था वो प्लीज एक बार रिपीट कर दीजिए वो मैं लिख नहीं पाई
अच्छा उसका आप स्क्रीनशॉट ले लीजिए ये रहा
हाँ जी सर एक बार दिखा दीजिए उसे
ये दिखा है ना देखिए दिख रहा है आपको
जी सर ले लिया स्क्रीनशॉट ले लिया हो गया
ओके ठीक है मैं आगे बढ़ूं
जी सर
मैंने एक क्वेश्चन पूछा आप लोगों ने ये जो सब्जेक्ट था एब्स्ट्रैक्ट अलजेब्रा में पढ़ा आपको मालूम है एब्स्ट्रैक्ट का मीनिंग क्या होता है हाँ okay so now we are defining an abstractive space. What does it mean by abstract? By an abstract space, okay, I am writing this, it is important. By an abstract space, we mean a set of points together with some axioms. Axioms defined on it. And when these axioms get changed, they are changed, then the structure, the corresponding structure on the space that get changed. Okay? So this is what the meaning of abstracting. So I said vector space is also an abstract space. So this means there are some axioms on a set of points. Okay, let's do this. What is a vector space over an arbitrary field? So in notes that I sent to you yesterday, I choose the field of a real number. So we can replace that R by any field K. Let K be a field. I am assuming you all know what a field is. Okay, let K be a field and X be a non-empty set. Okay, the set X is called vector space. The set X is called vector space over the field K if we have two operations. So if there exist two operations means two functions. So as I said, a vector space is similar as the solution set of a homogeneous equation, a homogeneous system. So there we took two operations. Number one, addition. Number two, scalar multiplication.
Scalar
Scalar
multiplication.
So
Scalar
there,
multiplication.
in fact, these are two functions. So first one is addition. So it is defined on the twofold Cartesian product of x to x. And how do we define this? We take 2 points x and y. So
From
the
this set.
element in of set x, so elements in x cross x, they are written in ordered pair. So this is going to x plus y. This is mapped to x plus y. So this is addition. It is called vector addition. And there is second thing that we denote by dot, and it was scalar multiplication. We multiplied a vector by a scalar alpha. So alpha came from the field K and the vector came from X. So the scalar multiplication is a function defined on the Cartesian product K cross X, and finally it takes values in X. So this means if you take alpha from K, X from the set capital X, and if you do this thing, you will again land in X. Okay, so this means this is called a scalar multiplication. Okay, so we have two operations. And they satisfy the following. Satisfying the following properties. So for writing the properties, let me mention here. Does it called? Is it called binary? Yeah, it is called binary operation. Do you know what is a binary operation?
यस सर
हाँ, ऐसे ऑपरेशन
सर
को बाइनरी ऑपरेशन
सर बाइनरी
है ना?
ऑपरेशन को क्लोजर प्रॉपर्टी भी बोलते हैं सर। इसमें क्या होता है कि अगर कोई भी सेट हो और उसका मतलब जैसे एस हमने एक कोई सेट लिया नॉन हेलो
हाँ बोलिए
हाँ तो सर एस क्रॉस एस का अगर
बोलिए।
यहाँ पर ये एक फंक्शन होता है तो जो कि एक्स क्रॉस एस से एस पर डिपेंड होता है कि इस प्रकार से अगर हम एस क्रॉस एस का कोई भी एलिमेंट ले रहे हैं तो एस में एक यूनिक एलिमेंट उसके करस्पॉन्डेंस एग्जिस्ट हो रहा हो तो हम कहते हैं कि ये बाइनरी ऑपरेशन है या फिर इसको हम फंक्शन भी वो क्लोजर भी बोल सकते हैं क्लोज्ड है।
I think what Priya is saying is that X belongs to the same set X. If this happens, this operation is called closed operation or a binary operation, and this property is called closure property.
यस सर
Is it what this is what you were trying to say? Correct?
यस सर
Okay. So let's move ahead. Let's see what condition this is satisfied. Number first is the addition is commutative. Second thing is addition is associative. So 0 plus x equal to on, let's say x we will get 0. Let's filter. Addition now properties with respect to scalar multiplication. So scalar multiplication distribute.
सर आपकी वॉइस ब्रेक हो रही है।
Property x equal to alpha alpha beta k. Whenever we multiply any x,
Sir, your voice is not clear.
नहीं है।
सर वॉइस ब्रेक हो रही है आपकी।
Hello. Yes, sir.
मतलब घर के झगड़ों को लेके बच्चे अगर इन्वॉल्व
No.
Sir.
Okay. Okay. Something happened. I don't know what happened. Wait for a minute. So is my screen visible?
No, sir.
Is it visible now?
No, sir.
सर
No, sir.
Yes or no?
Yes.
सर
Okay.
ऑडिबल
So-
है, विजिबल नहीं है।
कुछ लोग कह रहे विजिबल है।
सर विजुअल
ओके
है।
कोई बात नहीं, ठीक है कोई नहीं, मैं कंप्लीट कर चुका हूँ। बस मैं ये कह रहा था, इफ यू रिमेम्बर लिटिल बिट ऑफ ग्रुप थ्योरी, you will realize or you will observe that with respect to x, this x forms a commutative group. X is an abelian group with respect to addition. Do you see this?
Yes, sir.
यस सर, कैन सी दिस।
Okay. So with respect to addition, this is commutative group. So if someone asks you what is a vector space, so vector space is a field. Vector space over a field is a group with respect to addition, and it satisfies few properties with respect to that scalar multiplication. Okay. So in next lecture we will see some examples of vector spaces, and then we will move on. Okay then, bye. Drop your comments.
थैंक यू सो मच सर।
Thank you, sir.
Sir.